In this video, you'll see the process Nissan goes through to manufacture their cars. In addition, we'll showcase key terms used in manufacturing, call attention to relevant equipment utilized in processes like this, and finally, draw attention to challenges manufacturers commonly face along the way. Let's begin. Nissan is a manufacturing company who makes cars and automotive components. Their shop floor is semi-automated, meaning it is made up of automated equipment, but also manual steps and assembly to combine the parts for finished goods. The products manufactured at this facility have been designed by the engineering team using a variety of CAD and PLM tools. Production is made up of several different locations which manufacture different parts and product types. This is where somebody at the BU or leadership level would want to compare plant by plant or product by product manufacturing performance. The cycle time for a finished car is 24 hours. This means the duration it takes to manufacture one unit end to end is 24 hours, but is usually broken down and measured at individual steps. There are 5 manufacturing processes we will cover for producing an automobile at Nissan today. These include stamping, welding, painting, assembly, and inspection. The metal being stamped is cut into various sizes, which are determined by the parts required in the job order. Job orders often come from an ERP, or Enterprise Resource Planning System, which is a tool used to coordinate business activities and planning, usually external to the shop floor. In order to plan how many jobs can be completed in a shift, day, week, or month, the planner needs to know the manufacturing capacity, or the number of items that can be produced in a specific period of time with the available resources. After stamping comes the welding process. A sample scenario that may occur with equipment like welding machines is that they may go down due to an error. This is considered unplanned downtime, or downtime that occurs unexpectedly because of a failure. When unplanned downtime occurs, no value is being produced as the line stops manufacturing. But the cost of overhead operations continues to grow, which directly impacts a company's bottom line. The machine includes a PLC, or Programmable Logic Controller, which is a piece of hardware that is a physical interface between the machine and systems a user can interface with to understand data coming off of the equipment. Operators can see on the HMI, or Human Machine Interface, an alarm indicating an issue. This data was communicated from the PLC. An HMI is a part of a SCADA, or Supervisory Control and Data Acquisition software system that helps to control the industrial processes on equipment. In this case, the HMI is the interface between the worker and the equipment the worker is operating. Between the PLCs, HMI and SCADA, MES, and IoT solutions, there is a lot of data generated and used throughout the process. This high-speed, granular data often gets stored in a historian, or a type of database designed to collect and store records of time series data. After welding, the body manufacturing continues with the molding process. These components then get sent to the paint department. Many of the parts will be moved from process to process using conveyor belts or transport systems. This process is an example of a combination of manual and automated equipment working together. After the paint, the operator sees that the body has defects which caused bad quality parts, or scrap, that came off the line due to the failure. Scrap is defined as manufactured material that is unable to be part of a finished good due to quality errors. Because the scrap material does not add value, it's considered wasted material and time that gets included in the cost of poor quality. However, in this manufacturing process, the scrap material may be reworked or remanufactured versus being thrown out. This typically happens as a separate manufacturing process, but it's still costly to the organization. In cases where the process is automated, such as the robot arms here, the manufacturer may also use SPC, or Statistical Process Control. SPC is a statistical method of quality control that collects and analyzes the data from product and process measurements in real time, with the goal of monitoring and reacting in real time to process changes that may produce bad quality. Unplanned downtime and scrap were just two examples of losses that could occur during the process. But here, in the assembly, you can see other manual and automated interactions the operators are having. They could experience losses due to labor-related slowdowns, small stops, changeovers between materials, or planned downtime, such as maintenance. Any of these losses will disrupt the line and make the actual cycle time slower than the target cycle time, and therefore result in not meeting the production target within the designated time for job orders. There are a variety of tools used in the process, but here you will also notice a torque tool connecting the tires and conveyor belts moving the cars down the line. These tools shown here are examples of pieces of equipment we can connect to with IoT to capture data on quality parameters or control characteristics coming from manufacturing engineering. Quality inspection is an example of a module that may exist in a QMS, or Quality Management System, which is used to document processes, procedures, and responsibilities for achieving quality objectives. This data may get sent to the MES, or Manufacturing Execution System. It is likely much of the data made during the production process gets leveraged in an MES. An MES can manage, monitor, and synchronize the manufacturing process. It can coordinate the execution of job orders that come from the ERP system with scheduling, as well as track all key characteristics of the process and product data, such as where, when, and how a finished goods piece was manufactured for traceability or genealogy. Now that the manufacturing process is complete, the vehicles will be distributed to customers and vendors all over the world. Many customers are struggling to meet demand and deal with supply chain issues, which is why it is so critical to optimize production processes and maximize efficiency. Now, let's hear from shop floor personas about how the shop floor handles changes in demand, new product introductions, and the desire for increased efficiency.
First cash guy hitting the multi-million mark was great. We were in a stage where the more we can build, we can sell.
The volume just continued to increase, so we were challenging the plant in terms of what volume we could produce. You are getting the repeat customers. That goes down to the quality and hard work that goes into each and every cash guy.
The challenge with cash guy was because Nissan was first. When you bring the second generation and the third generation out, can you keep the successful formula going? Can you make it better? And I think every time we've proved we can. As soon as we build the car, we'll look to improve it the next time, and we'll look to improve how we manufacture it.
You heard the plant personnel talking about manufacturing each version as good as or better than the previous models. One way to measure this is by evaluating the OEE, or overall equipment effectiveness, which is a measurement some manufacturing companies use for understanding manufacturing productivity. OEE is made up of availability, performance, and quality, and is useful in understanding productivity, but often lacks 100% of the data needed for actionable problem solving. In the Nissan example, they are also focused on understanding the NPI, or new product introduction process, to make sure they are optimizing the manufacturing process from the start. Manufacturing is a complex, challenging, and interesting domain. It builds the world around us, and understanding your customers' processes and challenges are critical.